Hello and welcome back. Okay, so here's the CPU. I've got the Fibonacci ROM in here and that should work outputting to the LCD. I like this as a basic piece of test code, but if we fire the CPU into fast mode, it will complete virtually instantly. Now this ROM is in this ZIF socket, which maps to the bottom half of memory directly. So any address up to 32,767 accesses the ROM directly. And so at the moment we can see it's attempting to fetch an instruction from the ROM which has nothing in it. Now, I've been working on this circuit as a supplement to memory. Now this is a little bridge module that allows me to have a RAM and a ROM chip indirectly plugged into the socket. And then this circuit handles a reset to copy the contents of the ROM into the RAM so that then the processor can go on and execute with nothing but RAM, which is the configuration I really want. So this would plug in here like this, and then we need the memory address connections plugged in over here. But this is all quite unwieldy, and the ultimate plan was obviously to replace the memory module with a simpler system that combines all of this functionality. And I'll be back to having a ZIF socket for the program ROM, which would copy it into the RAM. So let's take a look at doing that. Okay, there is one extra thing I'd like to do. Now, I did the load for the parallel load lines from the inverted memory acknowledge line. But I think what I'd actually like to do is AND that with the start copy line. Now, this is the line that's going to be brought low by the reset circuit. And the reason why I'm doing this is because it occurred to me that there's no guarantee that these counter chips are going to start at 0. They do seem to always start at 0, but it's probably not smart to assume it. Okay, something else I want to look at is the use of this 138 chip here. Now I'm using that as a demultiplexer chip, but I'm only using 2 outputs. So logically, chip enable 1 is equal to address 15, and chip enable 0 is the inverse of that. But what we're expecting this chip to do is make it so that those lines change at the same time, because we don't want 2 chips to be pushing to the same data output at the same time. But I'm going to do this a different way. So the idea here is we wanted the enable and disable of the relative devices to happen at the same time. So if we just stuck an inverter in there, one would happen before the other by whatever the latency of that inversion was. But a commenter on one of my videos pointed out that you could do the same job with a pair of exclusive OR gates. Now we're going to pass address 15 in as the first input on the exclusive OR. But chip enable 0, we want that to be low if address 15 is low. So we want that uninverted. So for an exclusive OR, we can tie that to ground. And for the second one, we want to tie it to VCC. It can be easier if we do this one over here. So since we've just got exactly the same gates in both those lines, I'm assuming the transition should happen at the same time. But we've got 2 exclusive OR gates free. Now we've got 3 OR gates here, 2 inverters, nothing's free up there. So now this chain of inverters was just being used as a delay. We don't need that anymore. Now we've got 3 OR gates and 2 exclusive OR gates, so we should be able to create more than enough delay. I wish I could work out exactly how much was needed. That was 4 gates, but inverters are as fast as they get. So I figure I can connect up one of these jumpers to give me a choice of the delay attached to that line. Because I'm pretty sure the right thing to do would be to have that delay as low as possible. I'm going to be honest, I've actually got a suspicion that I don't want any delay here at all, and there's actually another problem in bus control I need to track down. But this will give me the options regardless to make it work as best as possible. It's a shame, this technique's not actually saving me anything. Reset is one of those lines I sent to a lot of modules and then ended up not using it. Oh, it doesn't like me joining these together like this. But in this case, I can solve that very easily. Right, so we've got 8 additional chips. Okay, it really is going to be a tight squeeze. There's a lot of components to fit on there. Let's save ourselves some room by turning that. I think what I'm also going to do is remove these 541s. Now I don't actually have very much in the way of lines hanging off the address registers. And I'm going to be honest, I was kind of just consuming some space with those. There are plenty of other places in the build where I've used buses to just drive LEDs directly. That's good. I have started to avoid putting chips in upside down, but this is lining up really well. Okay, now I've packed all of that over there, this feels a whole lot more doable. And the majority of these lines just fit together. So if I can put these vertically, it will be so much easier. Oh, this is an interesting idea, putting this vertically here. Okay, that's absolutely awesome, because all of those address lines have got to come from here. Okay, I think this is a really good component layout. It's going to be a big job routing this, but I've been paying attention to where the lines need to go. This section is fairly self-contained apart from a few control lines. And then we need the address lines coming out from here and over to this chip. The data lines all cross here and the address lines converge down here. So I think this might be, if not an easy, but a not outrageous route. That's going to look awesome. I need to check I've got enough of these switches left, and I need to remember not to burn this one as well. Okay, let's get this ordered. Okay, let's have a look at this. So the other one here is the updated ALU result PCB. So I should be able to get rid of the bodges with this. And my biggest worry was that the footprint for this wasn't actually right. But that looks exactly what we wanted. Right, solder it up. Now adding the copy functionality means that this is now one of my higher component count boards. It's worth noting that I've had more problems from not getting enough solder on than the other way around. Some of those look slightly sparse. I've actually realised that I want to remove the solder from these pads for this switch. I'll hand solder that on later, because we did find that those switches are not great with high temperature. And that's the decoupling cap for the 555. I think I used the same value for the main storage on it. All of those components around the 555 have some degree of flexibility on them, but they will affect the speed of the copy. If it's too fast, it might not work. If it's too slow, we can always speed it back up. That's the reset circuit. Very important to remember these latch chips are upside down compared to the rest of the board. That would be a pretty nasty mistake. I think I used the wrong pad for these. That looks like a 1206 pad. I have to watch that carefully. Let's get all the odd stuff out of the way. Luckily I saw where that one went. Oh, that's a pull-up rather than a current limiting resistor. Just a little MOSFET that drives the reset line. Preparing for this video, I had a horrible minute when I thought I'd lost those, but I eventually found the small number I bought down the back of the desk. Now I haven't changed the footprint from when I had trouble with these, but that was hand soldering and not using hot air. This guy's been nudged. Alright, I've still got a small number of 10 microfarads in 1206. It's just going to fit easier if we do that. I miscounted those, I've only got 8. It's kind of embarrassing to look at early videos where I get a bunch of LEDs wrong. Right, just the resistor arrays left now. These guys don't seem to have any markings on, so I don't need to worry which way they go. Gonna need a bunch more of these pins sometime soon. This is going disturbingly well so far. I had no right to expect that to all reflow as well as it did. Right, I do want to look a lot closer at the resistor arrays because we've had troubles with them before. I don't see any solder bridges. Assuming that makes a connection, everything has just gone really well here. Looks like the bit where I usually put my name didn't come out right this time. Serves me right for being subtle and not putting it in the silkscreen. Now on the back here I've put a series of jumpers, which is the delay between the load signal and the write line. Now load plus 3 is roughly equivalent to what it was in the previous circuit. But I do want to experiment with bringing that down lower because I think it should work despite the fact that we had problems on the breadboard circuit. So getting that to work and doing some experimentation with the timing I think is worthy of a video in its own right. Okay. So this is a really quite attractive looking PCB and it should slot in there. Now I've got absolutely no right to expect this to work first time, but it has powered up in copy mode, which is the one correct indication we've got. So the copy isn't happening because the address select isn't conducive to driving the bus lines. Now the counter is running, so it looks like the copy is happening. That's a bit slower than I'd like, so adjusting these resistors or this capacitor is in order. And now it's changed mode. Okay. Oh my word. That's actually working. Okay, I've had a few PCBs of late that haven't worked first time and I've had to go in and do a few bodges on, like this one on the ALU. But this is amazing. That's by far the most complex circuit I've had work first time. Results are correct. So I should be able to take this ROM out to prove that it's running from the memory, or from the RAM. There you go. So that's completed okay. Now I should be able to reset it and run it again. Run it in trace mode. Oh, that's brilliant. I'm so pleased with that. Okay, having this memory configuration where the whole of the 64K is RAM, but then we've got this extra circuit that copies a ROM in, is going to give me so much flexibility on how I work with this. Now, one of the next things I'm going to do is convert the UART onto a PCB, and then that's going to give me a nice, robust, stable connection. And I think at that point, it's a really good idea to write some code that works kind of like an Arduino bootloader, where I can use the UART to load a program into memory and execute it. and that's going to give me a far tighter method of developing code for the processor, because at the moment I'm blowing onto a ROM every time, and that's really quite time consuming. I don't want to give too much away, but having a lot more flexibility on how I assign memory as RAM is going to help me out with the new display circuitry I'm imminently going to start. So there, it's completed in trace mode all the way through to the end. I don't know what to say actually. I'm actually stunned that this great big new circuit worked first time, because I've had a couple of misses recently. So that is awesome. Okay, I really hope you found this whole process interesting. I'm going to be moving on to the VGA very soon now, and I'm getting quite excited about that. See you again soon. Goodbye.